Okay, once again, welcome to Login Science, guys. In today's video, we are going to solve question 2 from November 2020 from DBE. Okay, so the question will be covering arithmetic sequences and quadratic sequences. Okay, if you are still struggling with arithmetic sequences and quadratic sequences, I'll suggest you go watch my videos on quadratic sequences and arithmetic sequences. Okay, so I have a playlist on sequences and series. Please go find it and watch my videos on arithmetic sequences and quadratic sequences. Okay, so in today's video we are going to solve question 2 from November 2020. Okay, so this is the question. You can see it's question 2 from November 2020, and you can see we have 5 questions in total. So we have 2.1, and on 2.2 we have 4 sub questions. Okay, so the total is 17 marks. Okay, let me get started on the next slide. Okay, let me get the question again. So it's question 2 from November 2020. Okay, this is the question. We are starting with 2.1. So 2.1, we are given 7x, y, and negative 11. This is an arithmetic sequence. Okay, the question is to determine the values of x and y. There are many ways in which we can solve this question. Okay, the way to solve this question can also be by making 2 different equations. Okay, we can make up 2 different equations, okay, from this sequence. Okay, let's see that. So 2.1, this is an arithmetic sequence. We have x and y. We need to find x and y. Okay, so we have 2 unknown. If we have 2 unknown, we need to create 2 different equations to solve for the 2 unknown. Let me say that again. If we have 2 unknown, we need to create 2 different equations to solve the 2 unknown. Okay, remember this is an arithmetic sequence. So when they say it is an arithmetic sequence, you understand that there is a common difference between the terms. Remember that from the lesson. Please go watch my video on arithmetic sequence. You will understand that there is a common difference between the terms. So since there is a common difference, if I take this term minus this term, it is also equal to this term minus this term. It is also equal to this term minus this term. So you always take the next term minus the previous term is equal to the other next term minus the previous term. Always the next term minus the previous term is equal to the other next term minus the previous term. This is how you find the common difference. You take the next term minus the previous term to get the common difference for an arithmetic sequence. So this is the arithmetic sequence that we are given: 7, right, x and y, and negative 11, and so on. This is the arithmetic sequence we are given. Now let's create the 2 equations. So I can take this x minus the previous one, which is 7, right? This is also equal to, if I can take any next term minus the previous term, so I can take y minus x. Okay, this is equal to y minus x. Why do I say this? Because there is a common difference in all of them, which is the same value. So you can take this next term minus this previous term. It is the same if you take this term minus this previous term. It is the same if you take this next term minus the previous term. You are going to find the same value. And let's call this our first equation. Okay, this is our first equation. Let's create another equation. So I can take any next term minus the previous term is equal to any next term minus the previous term. Okay, I can take this one, y minus x, right? Y minus x, as long as it is the next term minus the previous term. This is equal to, I can take this one minus this one. So negative 11 minus y. Okay, because there is a common difference, this is why this is equal to this. So in an arithmetic sequence, there is a common difference. Okay, and this is our second equations. So I can close this. We want to determine the values of x and y. Let's close this. Okay, now we have 2 equations. So from the 2 equations, we can solve for the 2 unknown. The 2 unknown are x and y. We need to create a third equations. We can create a third equations by using equation 1 or equation 2. and we are going to make x or y the subject of the formula. The simplest one we can use, can you see, we can use equation 1, because I can say y is equal to, when I take this negative x to the other side, it becomes plus x. So you have x plus x, it will be 2x minus 7. So I can say from equation 1, you have y is equal to, you have x plus x, which is 2x minus 7. Okay, I hope you are not confused. You have this y there, and you have this negative x to the other side. You have now x plus x, it's 2x, and then you have negative 7. And this becomes our third equations. Okay, now what we have to do is to take the third equation and plug it inside 2. Do not plug it inside 1, because 3 is obtained from 1. You cannot take it and plug it back inside 1. No, plug it inside 2. Okay, so you have 3, equation number 3 into equation number 2. Okay, so this is equation number 2. Let's plug this 3 into 2. Now you have, this is 2. You have y minus x. What is your y? This is your y. Y is equal to 2x minus 7. So you take this, you substitute for y. So you have y there. You are going to put this 2x minus 7, right? Minus x, right? This is your y. You have y there minus x. Okay, so you substitute this in the place of y. This is equal to, you have negative 11 minus y, right? Minus, what is your y? This is your y. Remember, you substitute this for y. Okay, there. Okay, and you carry on. So you have 2x minus 7, right? Minus x, okay, is equal to minus 11 minus 2x. Remember, the negative is going to affect everything inside the bracket. So you have negative 2x and then plus 7. Okay, and so you carry on. Now you have 2x there minus x. Can you see 2x minus x is equal to x? So this is 2x minus 1x, right? 2x minus x is equal to x plus 2x. When this negative 2x comes to the other side, it becomes plus 2x. So you have 2x minus x plus 2x. So this gives you 1x plus 2x. You have 3x. Okay, is equal to, now you have on the right side, you have negative 11 plus 7. Okay, and we have negative 7 there. You bring it to the other side, it becomes plus 7. So you have 7 plus another 7, which is 14. 14 minus 11, which is 3. I hope you can see that. Okay, and so you need to solve for x. What are you going to do? You are going to divide by 3 on both sides. When we divide by 3, you have x is equal to 1. Okay, now you have the value for x. Let's find the value for y. You can use this to find the value for y. So you have y is equal to 2x minus 7. So you have 2 times x. What is x? You substitute 1 for x, right? Minus 7. Okay, I hope you can see that. And then you have y is equal to, this is 2 minus 7, which is minus 5. I hope you can see that. So x is equal to 1, y is equal to minus 5. Okay, now let's do question 2.2. Let me get the question again. It's question 2 from November 2020. And now we are doing question 2.2. Okay, so 2.2, we are given a quadratic number pattern. You can see this is the quadratic number pattern or a quadratic sequence. Okay, so you have 2.2.1, determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c, 4 marks. Okay, so 2.2, and we are solving 2.2.1. Okay, so we need to determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c. Okay, we need to determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c. So this is a quadratic number pattern or a quadratic sequence. So you need to get your A, B, and C, and you are done solving the question. Now, this is the quadratic number pattern or the quadratic sequence that you are given. You have -3, 6, 27, and 60, and so on. Okay, so this is the pattern that you are given. This is a quadratic number pattern or a quadratic sequence. You need to determine the general term in this form. Okay, let me close this for now. So let's get the first differences. Okay, to get the first differences, you are going to take the next term minus the previous term, the next term minus the previous term, the next term minus the previous term, always. Okay, so you have 6 minus -3, right? 6 minus -3. What is the difference? When you take 6 minus -3, the difference is 9. Okay, and what is the difference here? Between 6 and 27. You take 27 minus 6, it will be 21. Okay, and what is the difference here? Between 27 and 60, you take 60 minus 27, the difference is 33. Okay, so you can see this is not a common difference. Okay, for a quadratic number pattern, the common difference is only found on the second differences. Okay, this is the first differences. Okay, now let's take the second differences. So to take the second differences, you take this next term minus the previous term. What is the difference between 9 and 21? So you have 21 minus 9. The difference is 12. 21 minus 9, the difference is 12. I hope you can see that. And what is the difference between 21 and 33? You have 33 minus 21. The difference is 12. You can see now you have a common difference. 12, 12. So it will continue being 12, 12, 12, 12. Okay. Now to get your A, B, and C, you are going to use these numbers, the numbers in the diagonal. I want you to remember this. Use the numbers in the diagonal. You have -3, 9, and 12. Always use the numbers in the diagonal. So use these numbers. This one, -3, 9, and 12. If you want to determine your A, B, and C. So this 12 is equal to 2A, right? 2A is equal to 12. And this 9 is equal to 3A plus B. So you have 3A plus B is equal to this 9. And this -3 is equal to A plus B plus C, right? A plus B plus C is equal to this. Always use the numbers in the diagonal when you are trying to determine your A, B, C for a quadratic number pattern. Now from here you start with this one because this one has got one unknown, which is A. So you have 2A is equal to 12, right? So what is A equal to? You divide by 2 on both sides. You have A is equal to 6, right? And then you go to this one. This one has got 2 unknown. Now you know your A is equal to 6. So you have 3A plus B is equal to 9, right? And we have 3 times A. A is 6, right? You have solved for A, which is 6, plus B is equal to 9. And this is 3 times 6, which is 18. When you bring it to the other side, now you are going to have 9 minus 18. And so B is equal to -9 because 9 minus 18 is -9. And you go on to this one, which has got 3 unknown. You have A plus B plus C is equal to -3. Okay. A plus B plus C is equal to -3. Okay. And you know your A is 6, right? And your B is -9. So you have -9 there, plus C is equal to -3. Okay. You have this one, 6 minus 9 is -3. You bring it to the other side, it becomes +3. So you have 3 minus 3, and so C is equal to 0. I hope you can see that. This is -3. You bring it to the other side, it becomes +3. Now you have -3 plus 3, which is 0. So you have solved for A, B, and C. Okay. Now let's get the general term in this form. Okay, so you have Tn is equal to an squared. What is a? A is 6, so you have 6 n squared plus bn. What is b? B is negative 9, so you have negative 9 n plus c. What is c? C is 0. Okay, so this is the general term in this form, and you are done. Now let's move on to the next question, which is 2.2.2. Let me make a line here, and let's do 2.2.2. Let me get the question again. What is the question? Question 2 from November 2020. Okay. So now it's 2.2.2. Calculate the value of the 50th term of the pattern. You need to get what? T50, right? T50. Calculate the value of the 50th term of the pattern. Okay. You need to get T50. You are going to use this general term. So you have it. It is Tn is equal to 6n squared minus 9n. And you need to get what? T50. This is what the question is asking you. Calculate the value of the 50th term. You need to get T50. So this is equal to, you have 6. So you have n there. You plug 50. Remember, it is square. Minus 9 times n. You plug 50 in the place of n. So you have 9 times 50. Okay. So you plug 50 there and you plug 50 there, because you are trying to get T50, the 50th term, the value of the 50th term. Okay. And so T50 is equal to, okay, now from here you need to use your calculator. Okay. I'm going to use my emulator. I have my emulator, this one. Okay. If you want it on your PC, just check in the playlist, the one saying educational software. So let's get T50. You have 6 times 50 in bracket to the power of 2 minus 9 times 50 in bracket. What is the answer? 14,000, right? 550, right? It is 14,550. Okay. So T50 is equal to this. Okay. Let's move on to the next question. Let me do it on the next slide. Okay, now we are going to do question 2.2.3. Okay, question 2.2.3. Let me get the question again. It's question 2 from November 2020. Okay, so this is the question. Now it's 2.2.3. The question says, show that the sum of the first n best differences of this pattern can be given by Sn is equal to 6n squared plus 3n. Okay, we have to show that the sum of the first n best differences of this pattern can be given by this. Okay, so this is the pattern they are talking about, and we have the first differences and the second differences. Okay, we need to get the pattern down first. Remember from the previous question, this is the pattern: negative 3, 6, 27, and 60. Negative 3, 6, 27, and 60. And we have our first differences and our second differences. Remember that from the previous question. Okay, so the question is to say that the sum of these first differences, you have to show that it can be given by this Sn is equal to 6n squared plus 3n. You have to show that to get the sum of these first differences, you have to use this. Okay, we are going to see that. So this is our first differences, right? And this is our second differences. I hope you understand that. So this is a quadratic sequence or a quadratic number pattern. Okay, now we have to show that the sum of these first differences, to get the sum of this, when you take this plus this plus this plus this and so on, you can use this formula to get the sum of these numbers, the first differences. Okay, let's close this for now. Okay, so if you can pay attention, when you look at the first differences here, you can see the first differences here, they have a common difference of 12. Do you understand that this is actually an arithmetic sequence because it's got a common difference, and the common difference is 12. This is a quadratic sequence and this is an arithmetic sequence. I don't know if you can see that, because this is a common difference, which is 12. It's 12, 12, 12, 12. And this is an arithmetic sequence. You understand that an arithmetic sequence has got a common difference. an arithmetic sequence has got a common difference. Remember that from our lesson on arithmetic sequence. Please go watch that video on arithmetic sequence. So the first differences of a quadratic sequence is actually an arithmetic sequence. So when you are dealing with an arithmetic sequence, there is a formula that you have to use in order to get the sum to some numbers. This is the formula. If you can remember it from our lesson, this is the formula. And this formula is given on the information sheet together with the question paper. Okay, so you can use this formula or you can also use this formula. But you can see in this one, you can't use this formula, the one in red, because for you to use this formula, you need to know what your last term. This is the last term and this is the first term. A stands for the first term, L for the last term. You don't know what the last term is. The last term is not 33 because it still continue. Remember, the last term is not 33. So you can't use this formula. You're only gonna use this formula. So you need to prove that the sum of these first differences can be found using this formula from the question. This formula. This one here, Sn is equal to 6n squared plus 3n. You have to prove that you can get the sum of these first differences using this formula. Okay, so we are going to use this formula, the one in black, and prove that we can get what we have on the question. Okay, so what is your A? A is the first term, and your first term is 9, right? So forget about the quadratic sequence. You are not looking at the quadratic sequence. You're only looking at the arithmetic sequence, this one. This is an arithmetic sequence because it's got a common difference. So forget about this. Don't look at this. You are looking at this. So this is an arithmetic sequence, and the first term is A, which is equal to 9. And D, what is D? D is equal to the common difference. I hope you can remember this from our lesson on arithmetic sequence. Please go watch that video. So the common difference is equal to 12, right? And so let's use this formula. Sn is equal to n over 2, right? You have your square bracket, 2 times A, so A is 9, so 2 times 9, right? Plus, you have n minus 1, times D, D is 12. You close your square bracket. You can carry on. Sn is equal to n over 2. You have, this is 18, right? 2 times 9, 18. Plus, you have 12 times n, which is 12n. You have 12 times negative 1, which is negative 12. You close your square bracket. You can carry on. Sn is equal to, you have n over 2. And then you have 12n, right? 12n. And then you have 18 minus 12, which is 6. So you have plus 6. Okay, you close your square bracket. You can carry on. Sn is equal to, so you have now 12n times n over 2. Can you see? 12n times n over 2. So you have 12, you divide it by 2, it's 6. And then n times n, it's n squared, right? N times n, n squared, 12 divided by 2 is 6. And this plus, you have 6 times this. So you are multiplying this by everything in the bracket, in the square bracket. And then now you have 6 times n over 2. So it's 6 divided by 2, which is 3, n, right? 6 divided by 2 is 3, and then n, so 3n. Can you see we have proved? Can you see that from the question? As simple as that. Can you see? Sn is equal to 6n squared plus 3n. And we have proved. As simple as that. Okay. So this question is not complicated. Now let's do the next question, 2.2.4. Let me make a line here and do 2.2.4. What is the question? 2.2.4. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060? Okay, let's get the quadratic number pattern down so that you can understand this question. This question, you need to understand the English so that you can solve it. Okay, this is the quadratic number pattern as we have it from the previous question, right? We have it here, 27 and 60, right? And now you have terms there after 60. You don't know how many terms. And then you have this term, 21,060. Like this. Can you see? 21,060. This is a term in the quadratic number pattern. So in the quadratic number pattern, that has a value of 21,060. So you have 21,060 in this quadratic number pattern. So you have -3, 6, 27, and 60. After 60, you have terms. You don't know how many terms. And then you have 21,060. And after that, you have other terms. You don't know how many terms. So it's going to infinity. Okay. Now the question is to find how many terms you need to add to this. How many first differences you need to add to this first term to get this value. Let me close this. So if you can get the first differences as we did it in the previous question, this is what we have, right? Between -3 and 6, the difference is 9. Between 6 and 27, the difference is 21, right? Between 27 and 60, the difference is 33, as you can see. And so the common difference here is 12. Between 9 and 21, it's 12, right? And between 21 and 33, the common difference is 12. So you have 12, 12, 12, 12. Okay, so these are our first differences, right? And these are our second differences. Now, if you read the question, you need to understand the English. If you read the question here, what is the question saying? How many consecutive first differences? These are our first differences. How many do you need to add to this first term for you to get this? That's what the question is asking you. And it is simple. Let me do the question. So if you can look at the pattern here, you have to notice something. For example, if you look at this, this is T4. This is the fourth term, right? This is T1, T2, T3, and T4. How many first differences do you need to add to the first term for you to get T4? You need to add 3. 1, 2, 3, and then you have the fourth term. To get T4, you need 3 terms. To get T3, you need 2 terms. To get T2, you need 1 term, right? To get T10, you need 9 terms. To get T20, you need 19 terms. To get T25, you need 24 terms, right? And so on. So you need to get first the position of this term. You need to find it. Okay, so to get the position of this term, this is a quadratic number pattern or a quadratic sequence. So you can use this from the previous question. Remember, we determined the general term in the form an squared plus bn plus c, and we found it was this from the previous question, question 2.2.1. I hope you can remember this. Okay, so let's use this and find the position of this term. So you are going to replace Tn with this, right? Is equal to 6n squared minus 9n, right? And so you have 6n squared minus 9n. You take this to the other side, it becomes negative 21,060. This is equal to 0. You only remain with 0 on the left side. Okay, so I can take this, put it on the left side like this, is equal to 0. This one, and put it here, is equal to 0. So I'm just changing the side. So do not be confused. Or you can leave it like this. Okay, but I want to have it on the left side and have my 0 on the right side. I didn't change anything. And what we have to do is to get the coefficient of n squared equal to 1. Can you see I can divide by 6 throughout? So you divide by 6, you have n squared minus, you divide 9 by 6, you have 3 over 2, right? 9 by 6, you have 3 over 2, and minus, you divide this by 6, what do you get? You can use your calculator, don't stress. I have my emulator here. So you have this, you divide it by 6, you are dividing by 6 throughout. This divide by 6. Okay, this is the answer, right? Is equal to, you divide 0 by 6, it's 0, right? So you divide by 6 throughout, you have this. Okay, now from here, what you have to do is to factorize. Okay, to factorize this, you don't need to stress. Just use the quadratic formula. Don't stress. Use the quadratic formula. You are going to find the value of n. So you have this, n is equal to, this is the quadratic formula. You have it given on the information sheet together with the question paper. So I don't have x there because I'm not trying to solve for x. I'm trying to solve for n. This is why I have n there. And this is still the same as it is on the information sheet. So you have n is equal to this. Okay, you carry on, n is equal to, you have negative b. What is your b? Your b is negative 3 over 2, right? This is your b, and this is your c, and this is your a. Your a is 1, your b is negative 3 over 2, and your c is negative 3,510. So you have a, b, c. Okay, so you have negative and b, this is your b, negative 3 over 2, this one, plus or negative, right? And then square root. You have b square, this is b, negative 3 over 2, this is b, remember square, minus 4, right? 4a, what is a? A is 1, there is an invisible 1 there. And what is c? C is this, right? This one, over 2 times a is 1, right? Okay, so let me carry over here, let me put a line here. Okay, so what you have to do is to plug this in your calculator. Okay, I'm not going to do this, just do it in your calculator. Use plus there, and then after that use negative. When you use plus there, you are going to get that n is equal to 60. When you plug this in your calculator and you use negative there, you are going to get n is equal to negative 58.5 or negative 58,5. Okay, so you can plug this in your calculator. I hope you can do that. So now you can see n, which is the position of this term, cannot be negative. You have negative 58.5. So let's reject this, right? N is not equal to this. So n is only equal to 60, right? So you understand that T60 is equal to this because you have n equal to 60. T60 is equal to this, okay? Because this is T1, T2, T3, T4, and T60 is equal to this. So now from here you understand that 59 first differences were added to this first term to get this, right? Because T60 is equal to this, you need to add how many? 59 terms. Okay, so you can conclude that 59 consecutive first differences were added for you to get this. So you need to add 59 terms. 1, 2, 3, 4, 5, 6 until 59. Then you can get this. Okay, so this is how you can solve this question. As simple as that. We are done with question 2 from November 2020. Okay, if you find value in the video, please show that with your likes. Comment in the comment section. Remember to subscribe and activate the notification bell so that you know when new videos are released. Okay, until next time, I will talk to you soon.